Welcome. In this lesson, we're going to solve right triangles, which all that means is they're going to give us a right triangle, where we'll know there's a right angle, a 90-degree angle, and they'll give us two of the measures of either one of the angles, one of the sides, maybe two angles, two of the acute angles. But what they mean by solve is find all the other missing parts. So for instance, find the measure of angle G here. Find the length of side GF, find the length of side HF. And it says to write your answer in simplified rationalized form. I would write down these two special triangles, go back and review the lesson we had on them, the 30-60 right triangle and the 45-45 right triangle, where the side lengths are 1, 1, square root of 2 for the 45-45 right triangle. The side lengths are 1, 2, and the square root of 3 for the 30-60 right triangle. And then you can know that if I want to find these sides, I'm going to use these ratios. What I mean by that, let's first find the angle. It's very easy to find the measure of angle G. All three angles add up to 180, or since this one's 90, the two acute angles must add up to 90. The measure of angle G plus the measure of angle H must add up to 90. But look, H is 60, so the measure of angle G is 30. So I know right off the bat that the measure of angle G is 30. Now this is a 30-60 right triangle. So I'm going to first say, oh, look, if I take the sine of 60 degrees, which is going to be, now again, you need to identify which sides are the hypotenuse, which side is the opposite. If I'm referring to angle, the 60-degree angle, this would be the opposite. So the sine of 60, that's a really poor opposite, would be the length GF over the length of the hypotenuse, 12 square roots of 19. But remember, the sine of 60 is a fixed ratio. It's the square root of 3 over 2. Square root of 3 over 2, not 1. Square root of 3 over 2. So then all I need to do is I need to solve this expression for GF by multiplying this over. I mean, ignore this part right here. Just notice this simple ratio. Multiply it over to find the length of GF. And then that's going to simplify. 12 over 2 simplifies to 6. That's a 6, not a 12, and then I find out that that exact answer for the length of GF, or FG, is 6 square roots of 57. Then I do the cosine of 60. Cosine is this adjacent side. Adjacent, that's supposed to be a D, adjacent over hypotenuse. Adjacent over hypotenuse for a 60-degree angle, adjacent over hypotenuse is 1/2. That's the same as the length of HF over the hypotenuse of the triangle given. Multiply the 12 square roots of 19 over, reduce, and we get 6 square roots of 19 for this length HF. 6 square roots of 19. So again, we're using our trig functions to find these. So write these two trig functions down. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Let's do one more where I don't give you either angle measure. So here's one where it didn't give us either of the two interior angles, but it gave us two sides. Now, first thing I'm going to always do is label the hypotenuse, and then I'm going to start with referring to angle S, which would make this side the opposite and this side the adjacent, which allows me to realize I'm going to be using the tangent function. The tangent of S is going to equal the opposite over adjacent, or the square root of 22 over the square root of 66, which is the square root of 22 over 66, which is the square root of 1 over 3. Square root of 1 is 1, square root of 3. Now, I can either use a calculator to do the inverse tangent of 1 over the square root of 3, or I can look at those two special right triangles that I had in the last problem, go back and refer to those, and you could figure out that the tangent, who gives you the 1 over the square root of 3 ratio, is a 30-degree angle. That lets me know that this angle here is 30 degrees. Now that I know that's 30 degrees, which is angle S, the other angle, angle R, must be 60. And then I just use Pythagorean's theorem. You could do the sine function or the cosine function and set up ratios to solve for the hypotenuse, but I just thought it was easier to do Pythagorean's theorem, a squared plus b squared equals c squared. When I square a square root, it becomes just the 22. The square root is 66 is 66. That's 88. C squared is 88. Square root 88. We get 2 square roots of 11. And so, again, make sure you reduce. That's 4 times 11. So I'm just going to do 2 square roots of 11 for my final answer. Again, I went over this very, very quickly. If you have questions, please do bring them to class. And it looks like I did something wrong. Oh, I can't reduce my square roots well enough. You see what I did wrong? Right here, I had the square root of 88. And 88 is 4 times 22, not 11. So I didn't reduce right. I hope everyone realizes that. Remember, we had an 88 equals c squared. So c was equal to the square root of 88, which for whatever reason I thought, or oversimplified in my head, that that's 4 times 11. No, it's 4 times 22 is 88. Which one of those square roots? The 4 does to a 2, and it leaves a square root of 22, not a square root of 11. I had a square root of 11 here, and that's why I got it wrong. So be very, very careful when you reduce your square roots. If you have questions, please do bring them to class.